guys, today we're going to do 2 for average rate of change and tangent lines. So we know that the slope of a line is given to us by m is equal to change in y over change in x. So it's the rise over run. And the slope, if we have this function, f of x is equal to x squared, the slope at 1, 1 can be approximated by the slope of the secant through 416. So 416 is another point on our graph. So I could do 16 minus 1, which would be our difference in y values, over 4 minus 1, which is 15 over 3, which is 5. So that is an approximated slope between those 2 points. But as we move closer and closer, we get a more accurate approximation. So if I move to 3, 9, then I would do 9 minus 1 over 3 minus 2, which is equal to 8 over 2, which is 4. And then if I did 2, 4, 4 minus 1 over 3 over 2 minus 1, which is 3 over 1, which is 3. So as we keep getting closer and closer to the point 1, 1, our slope value is getting even more accurate. So the slope of a line is given to us by delta y over delta x. If we got really close to 1.1, say 1.1 and 1.21, the approximation would still get even better, so we would get 2.1. So how far could we go? Well, if we took this into limits and said that the function at 1 plus h minus the function at 1 divided by h, and we want the limit as h goes to 0, we take this into our function of h plus 1, into our function of y equals x squared. So then we would plug it in and get h minus 1 squared minus 1, which is from plugging 1 into x squared, over h. We FOIL, and we find the limit as h goes to 0. Here is a picture of it. We have our function, we have 1, and then 1 plus h would be how far away we are from 1. Then h is here, f of 1 plus h is up here, so we're taking our y values minus our y value of f of 1 plus h minus f of 1. And then we're left with 2h plus h over h. Over h plus h squared over h. Factor out an h, the h is canceled, we're left with 2 plus h. Therefore, our limit would be equal to 2, so that our slope would be equal to 2. And as we saw before, when we were getting closer and closer to the point 1, 1, our value was getting closer and closer to 2. So, the slope of a curve, y is equal to f of x at the point P, a, comma, f of a, is the limit as h approaches 0 of f of a plus h minus f of a over h. So that's what we just proved here. And the slope of the curve, that's the definition we just said. And this is called the difference quotient of f at a. So if you are asked to find the slope using the definition or using the difference quotient, this is the technique that we will be using. So the slope of a curve at a point is the same as the slope of the tangent line at that point. In our previous example, the tangent line could be found by using y minus y1 equals m over x minus x1. And if you want the normal line, we could use the negative reciprocal of the slope. So in this case, it would be negative 1/2 because our slope was 2. And our normal line is perpendicular. And just a review, average slope is equal to change in y over change in x. And slope at a point is equal to the limit as h approaches 0 of f of a plus h minus f of a over h. And then the average velocity is equal to the total distance divided by the total time. And then instantaneous velocity would be f of t, which would be the position function, so exactly where it occurs. And velocity is equal to slope. Therefore, the velocity is equal to the limit of h as h approaches 0 of f of t plus h minus f of t all over.